Okay, continuing on with this, if I put 0 in for the square root of x, the square root of 0 is just 0. If I put 1 in for the square root of x, the square root of 1 is just 1. If I put 2 in for the square root of x, now the square root of 2 is going to come out to be a really long decimal, so we're not going to use that one. And if I put, I'm going to want at least another point on the graph. If I put 3 in, the square root of 3 is also going to come out to be a really long decimal. But what about 4? If I put 4 into the square root of x, the square root of 4 is a 2, so that works. So I'm going to graph these 3 points on the graph. So it's going to be 0, 0, 1, 1, and 4, 2. Now it stops at 0, 0 because any of these negative values, remember, are going to give you imaginary numbers. So your graph's going to look something like this, where it stops at that 0, 0. It doesn't go past the 0, 0. So that's our parent function. So now what we're going to do is we're going to flip it over the x-axis. I'm going to do that in yellow. My 0, 0, since it's on the x-axis, is going to stay. My 0.11 flipped over the y-axis would put me right here. And my 0.42 flipped over the x-axis, would get me right there. So this is what your graph would look like just when you flip it over the x-axis. But we also need to translate it 3 to the right. So taking each of my yellow points and translating them 3 to the right, my 0.00 is now going to be right here. My 0.1, -1 is now going to be right here. And my 0.4, -2 is now going to be right here. This is your ending graph, so that's why I'm drawing that one in solid. All right. So it may be helpful when you're doing these transformations of these different types of graphs to know that you can create an x and y table using your parent functions to help you figure out what your original graph would look like before you do your transformation. So, number 10, we have not done this one yet. This is a cubic graph. In a cubic graph, your parent function is y is equal to x cubed. So if I go ahead and made my x and y table by picking my 5 random x values, -2, -1, 0, 1, and 2, if I put them into y is equal to x cubed, a -2 cubed is going to give you a -8. A -1 cubed is going to give you a -1. 0 cubed is a 0. 1 cubed is a 1. And 2 cubed is an 8. So let's graph this graph using a dotted line for my parent function. So I have 0, 0. I have -1, -1. I have the 0.11. I have the 0.28, which is going to go just 1 unit off the graph. So let's just draw it. And I have the -2, -8. So this is what your graph's going to look like. Oops, sorry, I want to do a dotted line. And now we're going to transform that by moving each of the points up 4. So starting with the 0, 0 point, if I move that up 4, that's going to put me right here. Doing the 1, 1 point, that's going to put me right here. Doing the -1 point, that's going to put me right here. And doing the -2, -8 point, that's going to put me right here. And that other 0.28 is going to be way off the graph. We don't need to draw that, but we can, by knowing the shape of the graph, we can do a rough sketch of what that graph's going to look like. It's going to look something like this. All right. Now number 11 is another x squared graph. So remember, if you know the general shape, you can easily just jump straight to that. So we have a point at 0, 0, a point at 1, 1, and a point at 2, 4. And then we have a point at -1, 1, because this graph has symmetry, and -2, 4. So this is your parent function. We're now going to graph this using our transformations. Now first we would do a reflection over the y-axis. If we did a reflection over the y-axis, guess what? This point that I highlighted in yellow is just going to move right to this point here. And vice versa, that point would move on to the other point. This point here would just reflect over to this point, and vice versa. And lastly, 0, 0 is just going to stay where it's at because it's on the y-axis. So reflecting over the y-axis puts you in the same exact spot that our parabola was originally at. Now that's not going to be the case with all graphs. For example, a square root graph, if I were to reflect this one over the y-axis, that would look something like this. Okay, so you got to be careful with these. It's not always going to be the same after you reflect it over the y-axis. It just happened to be the same with this one because this graph has symmetry. So then I'm going to shift my yellow graph now to the right 3 units and up 1. And that's it. So my point 0, 0, shifting it to the right 3 units and up 1, that puts me here. Shifting my point 1, 1 to the right 3 units and up 1 puts me right here. Shifting my point negative 1, 1 to the right 3 units and up 1, that puts me here. Shifting my point 2, 4 to the right 3 units and up 1, that puts me right here. And then lastly, shifting my point negative 2, 4 to the right 3 units and up 1 puts me right here. So this is my final location of my transformed graph. All right, and then we have one more to do, and that's another absolute value one. So again, if you know the parent function of an absolute value graph, it's going to be pretty simple to go based off the parent function. So here, my parent function starts at 0, 0, and I have a point at 1, 1, and 2, 2. Then I have a point at negative 1, 1, and negative 2, 2. This is what your parent function looks like. Now, there's a couple of transformations that are happening. My first transformation I'm going to do in yellow, and that is a vertical compression or shrink by 1/2. So what we're going to do is we're going to find the slope between my first and second point. So between 0, 0 and 1, 1, I go up 1 and over 1. And remember, I multiply my rise by my compression value, which is 1/2. So my rise is 1 times a 1/2 would be a 1/2. So that means your slope's 1/2. So that means from 0, 0, I go up 1 and over 2. Since this is an absolute value graph and my rise and overrun to my next set of points is just 1 over 1, then it's going to be the same exact slope between my second 2 points, up 1 and over 2. And then since this graph has symmetry, we can reflect those points over that y-axis to get my other 2 points. And this is what your graph looks like after just doing the vertical compression. Now I'm going to take that yellow graph, I'm going to transform it 1 to the right and 2 up. So starting at 0, 0, transforming 1 to the right and 2 up would put me right here. Starting at my next point, 2, 1, going 1 to the right and 2 up puts me right here. And then my last point, which is 4, 2, going 1 to the right and 2 up puts me right here. And then I can just reflect those points across to mirror them on the other side. Because, again, an absolute value graph has symmetry. So that's why we can do that. This is my final graph. All right, so that's transforming graphs.